Hello everyone, welcome back to Code to Serve Academy. So today we are going to see the first lecture of class 10, that is revisions of basic concepts of Java. We will learn all the concepts that we have already covered in class 9. Okay. So here we can see like the topics that we have already learned are the basic concept of OOPS. So you know what is OOPS, right? You have already learned the fundamentals of OOPS. We are going to cover that in the first chapter of class 10. Next chapter will be elementary concepts of class and object. You already know what is class, what is object. We will see the basics of that. But if you are in class 9, we will go into a deep dive sessions of class and objects in that lecture. But for class 10, we will be seeing the overviews and the important points that we have covered in class 9, right? Next topic will be values and data type and the remaining chapters that you have already covered, right? So in the first lecture, we will try to cover till values and data types, and the remaining topics we'll be covering in the upcoming lectures. Okay. So before this, let's see what is the syllabus for class 10 for ICSE 2026 exams. That is the next year that you are going to give your board exams. So let us see what is in the syllabus. So you can see the paper will be of 100 marks that contains the first chapter, the complete revisions of class 9, right? Including all the chapters, that is a chapter 1, introduction of object-oriented programming, till the nested loops and all, right? So you also need to learn what you have already covered in class 9, plus the new chapters that will be there in your class 10. Okay. And the remaining chapters like the class and as a basis of all computations, user defined methods, and so on. We will cover these one by one in the upcoming lectures. So stay tuned. If you have any doubts, post it in the comment section. We'll try to answer as much as possible. Okay. So let's get back and start our first lecture with the topic Introduction to Object-Oriented Programmers. So in the object-oriented programming, it refers mostly like what are the different features object-oriented programming offers. So in this, for your syllabus, we are mostly considered for Java, right? What Java offers. There are different programming languages such as C, C++, Python, and other programming languages. Most of the programming language that you see like Java, C++, these all comes under object-oriented programming pattern. So what is object-oriented programming patterns? You have already learned in class 9 what is programming paradigm. So if you don't know what is programming paradigm, you can understand with this way, like different persons have a different way or a different style of writing. You are getting the point. You will see somebody writes in a different style, in a different fonts. Similarly, in any programming language, there is a different way to code. So one type of coding that we say is an object-oriented programming. And we are mostly concerned with this paradigm, that is a programming paradigm. And what type of programming paradigms? Object-oriented programming paradigms, right? So coming back to Java, what is Java? You have heard most of the time Java. Java is just not a program or not a language. It is also a platform. What do I mean by this? Language, like you talk about some language, like English is a language, Hindi is a language, other programming language. We are talking mostly in the languages that we talk. Similarly, the languages with which we can talk to the computer, right? Those are Java, C, C++, and all. But with Java, Java is just not a language. It is also a platform. I'll talk about it, what platform means. But you understand the point here. Java is a popular programming language in today's generation. If you see, even if you want to develop website, backend, or mobile apps, you can use that Java as a programming language. You can write the code and you can develop these things, right? So it is very important to learn any object-oriented programming, right? and Java is one of them. Okay, so let's get started. I will explain about this, what is a platform and why Java is called a platform independent. We'll cover this in the upcoming slides. Okay, so let's talk about the history. How Java and why Java, right? So during the 1991, there was a company called Sun Microsystem. Okay, and in that company, basically there was a team. Okay, so team of 3 person, mostly more people would be there working in that team, and that team was called a green team. Okay, and I'm talking about 1991. So they were trying to solve a problem for a set-top box or a embedded systems. Like you have a TV, you see the set-top box. So for those embedded system, they were trying to build some software for those, right? So they were trying to build any software that will run in these systems. That is an embedded system, not for a computer, not for anything. But what happened, like initially you can see here, they were trying to build or design some system for an electronic appliances such as set-top box. Okay, but what happened? So they were trying to build such something like that, but the output became that was a programming language, that was Java. They were not trying to build any programming language. They were trying to solve one problem, and by solving that problem, they got one programming language. They developed one programming language. Getting the point? So initially the name was not Java. Initially the name was, as I mentioned you, the team that was handling was called as a green team. So initially what they developed, they named it as a green talk. What they mentioned, they named it as a green talk. In 1991, there was no concept of Java. There was no word Java itself, right? But initially it was called green talk, right? Why? Because they named it, they were working as a green team. The name was a green team, and the extension during that time was .gt. Gt represents G of green and T of the team. That is why the extension was kept as gt, right? But what happened after that, it was renamed to oak. Oak is also a name of a tree, if you know, like you can see, like it's a name. So what happened? They renamed it as a oak, but there was a lot of controversy after that, that they cannot keep this name and they cannot patent this as a oak. That is why they have to find some unique name that they can patent for. And then they came out with a new word that is called Java. So this was the basic of Java. So you should know what is the initial history of Java. You don't have to learn it, but you should know the basics, how it emerged, and who were the main role in that developing the language. So the first person was the James Gosselin, Patrick, and Mike, whom we call the father of Java. Generally, we call James Gosselin as the father of Java. So anywhere, if you find any MCQ question, who is known as the father of Java, so you should know that James Gosselin is called the father of Java. Right. Now, moving next, as I mentioned, they were trying to build interactive TV and set-top box for the electronic devices. There was no concept like they were trying to build or develop any programming language, but out of that, new programming language was developed. Okay, that was the history. Now come back to the fact what we are going to learn. So as I told you, our main focus is on which type of programming language? Object-oriented programming languages. And in object-oriented programming language, there is two things that you should know. One is class, and the second thing is object. Okay. So I told you, like, programming paradigm is a style of coding, way of coding, how you code, how you write, right? Similarly, in object-oriented programming, everything that we see in the terms of class and object. Whatever we see this classroom, we see this board, we have to think in the term of class and objects, right? So this board is what? It is an object. This stylus is what? It is an object. So you can relate it to a real world entity, right? This object is also a real world entity. Similarly, you can represent this in your programming terms as well. And that is why we have to pay more important to these two terms. That is, one is a class and one is an object. Okay. So let's see what is an, first let's see, it would be better, let's first see what is a class. A class is a blueprint representing a set of objects that shares the common characteristics and behavior. You might not understand by this point, but let me give you an example. Take an example. Suppose you are trying to build your home, right? You are trying to build your home. How and where you want to keep your windows, where you want to keep your stairs, and where you want to keep other stuff. Before this, before developing or before starting the construction of a house, you first go to an architect, right? An architect will give you a design of your home, how, where, and what all things you are going to place where, right? That means first you are trying to get a blueprint, right? Like here will be my one room, here will be the other room, here will be my other room, and so on. So this is what? This is a blueprint, right? And all the workers that will be constructing those buildings will use this blueprint to construct into an actual home, right? So this one that you see on your paper, that is not actual. On your paper that you see, using which we are going to construct an home, this is called a blueprint and this is called class. This is called class. And if you are constructing a home with this blueprint, an actual building that is constructed, that one we called as an object. I hope it is clear, right? So what is class and what is an object, you should keep in mind. This is the main difference between these two terms, and it is very important to understand this term, and you have to remember this for lifelong, right? Now if you see the definition, class is a blueprint that represents a set of object that shares the common characteristics and behavior. That means what? It is a blueprint, and using this blueprint, I can construct multiples of building, not just one building, but multiples of buildings, and all the multiples of buildings will share a common property. What is a common property? This building is having 4 rooms. Another building that I construct will also contain 4 rooms, 2 windows, similarly 2 windows. That means using this blueprint, if I construct 4 homes, all 4 homes will share the common properties, and that common properties are like 4 rooms, 2 windows, color of the wall, and color of the whatever color that you use. You are getting the point, right? So this was the concept of class and object. So coming back to object, now if you see what is an object, if you try to relate this term with a real world, what you see around you, then you will be able to understand what is an object. What is an object? Object is an entity with a specific identity. It's a very important term, specific identity, and having a specific characteristics and a specific behavior. You don't have to learn, but try to imagine, right? Like as I'm teaching, I'm a person, I have some characteristics, I have some appearance, I have some behaviors. My behaviors, your behaviors, and the other behaviors are all different. Similarly, an object contains a specific property and I have an identity. Like I have an identity, I have a name, you have a name. So that is an identity. I can uniquely identify you. Similarly, an object is also an entity with a specific identity. That means we can identify this object by the name, right? Similarly, they have some characteristics. Take an example. If I say fan, you see fan has, all the fan has a common property. If I take Havells fan, GM fan, or any other brand fans, all the fan will rotate. That is a behavior. All the fans have a common behavior that is called moving or rotating. But the brands are different. Brands are different. That becomes your identity. Like it is a which brand fan, that becomes its identity. And inside the brand also, there is a sub, what you say, sub branding. Like it is a take an example of a phone. If you take iPhone, iPhone is one brand. Inside that you have iPhone 13, 14, 15, and so on, right? So similarly, it is having an identity. So each object has an identity within a specific characteristics and behaviors, right? We are going to cover this in depth in the chapter 2 that we are going to learn about classes, right? But now in this revisions, we are just going to understand what this point means, right? If you have any doubt, just post it in your comment section, right? Okay. Next, we understood what is class and object. Now, as I was telling you, there are some properties associated with object-oriented programming language. What are those properties? So basic first one is your abstraction. So take an example. When somebody calls you, right? You see a dialer like this way. You see a dialer, name is written, who is calling you, and two buttons. One is a end and one is to receive, right? When you see these two buttons, you don't know actually how internally it is working. You know how, what is the coded inside this, what programs has been written. You don't know, right? You just know if I click this, I'll receive the phone. If I click this, I'll end the phone, right? So abstraction is act of representing essential features without revealing the background details. I'm not telling you what is written inside this. I'm not telling you what is written inside this and how this has been made. I'm not telling you, but I'm telling you what happens if you click this, what happens if you click this, right? So this is called an abstraction. You are not telling the user how I have made this, but you are telling the user how to use it, right? So this is what an abstraction is, right? So you can pause the video and you can see what I have written here. Like first point, act of representing essential features without revealing the background details. I already told you. And this also helps you in hiding the complex problem. I mean, hiding the complex detail and showing the necessary details. Suppose if you tell someone like you have to write 5 lines of a code to receive a phone call, so who doesn't know any programming language, they won't be able to receive it. That becomes very complex. That is why those complex things you are hiding inside a wrapper, and you are showing only two buttons using which a non-programmers can also use that, right? Similarly, the next point is it represent the external behavior of the object. Very important point. Just it is revealing the external behavior. That means what this button does and what this button does. That's it. Okay. Used in the terms of designs, right? Let's go to the next important concept, that is encapsulation. So it is very important term again. So encapsulation, you can think of a capsule, right? You all have eaten some tablets and all, right? Think of that. And if you think like that, so in a capsule, you see a different small type of tiny capsules inside that, right? So what is happening in that capsule? It is wrapping all the internal medicines inside one capsules, right? Similarly, if you talk in the terms of a programming language, that means if you are wrapping the data members and the member method into one entity, that becomes your class, and that class is called encapsulation, right? That class is called encapsulating the data members and the member method. Take an example. Let's quickly take an example of this. Suppose here is one class hello, and inside this there is one method. Suppose so. Take an example, what I'm telling you here. Take A as 10. If you see here, If you are in class 9, you won't know what program, how to write a program. We'll learn later. But if you are in class 10, you are familiar with this type of programs, right? Take an example like private A is equals to 10. What is private? What is public? These are access specifier. If you don't know, that's still fine. But take an example. If I'm telling private, that means nobody from the external world can access this, right? Take an example. You have a phone. Who has the access of the phone? You and your family members, not an external world. Not your external people is coming and using your phone. So private means only you can use something that can be utilized just inside that class, right? Similarly, public, that means what? Anyone can use. If you see the public transport, anyone can use, right? So this can be accessed by an external world. From the outside, I can access this, but from an outside, I cannot access this. Getting the point? So if something is declared as a private, suppose I'm typing the data type, I just missed the data type, private int equals to 10. This the data type is int. So here, what is happening? You don't have the access of this, but you have the access of this. And now you are wrapping both of them into a one unit, wrapping into a one unit that is called a class. And what is the name of the class? Name of the class is hello. So you can imagine this hello to be kind of a capsule that encapsulates data member and the member method. This is called the data member and this is called the member method. It can be private, it can be public, it can be anything, right? Similarly, take an example of this diagram. You have a TV. Suppose you have a TCL TV, you have a Apple TV, you have n number of different TV. But with one brand of TV, you cannot operate all the TV. For one kind of TV, you have one remote. Similarly, for different kind of TV, have a different remote. That means what? Take an example here. That means if I am authorized, if I am an authorized person to use this, then only I have access to this private member, right? If you have the, suppose this is your phone and you have the access, then only you are able to use it. But an external people or the external person cannot use this, right? Similarly, in this case, the remote you are seeing is accessed by the person and the brand of the TV can only be operated which supports this, right? That means this remote has access of this TV, control of this TV, right? So this becomes what? Encapsulation. So in a single term, what you can remember is wrapping of member method. This is a method, member method, and this is called the data member. That is whatever variable that you declare, that is called data member. And whatever functions you can have 10 number of functions and those functions are called data member method, right? So when you wrap the data members and the member method into a single unit, and that single unit is called what? Single unit is called a class. That is called encapsulation. I hope it is clear, right? Okay, let's move to the next topic, inheritance. This is also a very important topic. And in your higher classes, you will learn how to write or how to inherit. But for your scope, for class 10, you don't have to write the programs for this. But in your higher classes, as you go class 11 or maybe in engineering, you will learn how to inherit an actual program you will be able to write, right? Now, if you come here, what is inheritance? Similar to our generations, you take an example of yourself. You are inheriting the property from your parents. Your parents have inherited some property from grandparents, and so on. Similarly, in programming language also, we can inherit the property from one class into another class. So suppose this is parent, this is A, that is called a superclass, and B is a subclass. That means you can assume this as a parent and this one you can assume as a child, right? Now child, see, this is very important. You have to remember the arrow, which direction we put the arrow. Always the direction of the arrow is towards the parent. That means how we read it. Child is accessing the features or inheriting the features of the parent. That is why we are giving it an arrow up. Is. Here the concept of is coming. Child is inheriting the features from the parents, right? Similarly, so there are different types of inheritance. First type of inheritance is called single inheritance. Second one is multi-level inheritance. Third is a multiple inheritance. But in Java, multiple inheritance is not supported using class. Using interface, we can support. This is a very high level. Still, you just keep in one word, like keep in mind one top point, right? Java doesn't support multiple inheritance using class. It can support, but not with the class using an interface, right? This point is very important. Next is a hierarchical inheritance. I'll come to one by one. So here in single inheritance, you can see one child and one parent. That means here this child is inheriting the property from his parents. Done. That means I'm talking about the one level, that is a child and the parent. That's it. Similarly, if I talk to the two level or more levels, more than two level, if I talk, that becomes multi-level inheritance. So suppose this is a child, this is a parent, and this is a grandparent, and so on. So if there is more than two levels of inheriting, then we call it as a multi-level inheriting, right? Next is multiple inheritance. In multiple inheritance, what is happening? This is class. You can take an example. It is inheriting the property from two different class. That means two parents, I mean father and mother, and the child is inheriting the property, right? Common properties. But in Java, if you talk about, is directly, we cannot create multiple inheritance using class. This point you have to keep in mind. Next is hierarchical, right? Here you see this is a super class, and we have so many. I mean, this is also inheriting from this. This is also inheriting from this. This is also inheriting from this. In a programming language, what is the importance? You might ask question, what is the importance here? Why we are learning this? In a simple word, take this example. Take an example of a motor vehicle, like a car. You see, in the car, what are the main components? You have a gearbox, right? You have the wheels, you have the steerings, you have the body, right? And the different features are embedded. So each car will have what? Common engine, right? Suppose take an example. So you have one engine as a common. So what you do, you create engine once and you use it in multiples of car. So suppose one car, suppose ABC is one car, you will use the same engine, right? In XYZ, again, you are going to use the same engine, right? That means what? You are trying to inherit the same property, what that engine was having in the car A, car B, car C, and so on, right? You are not going to make new engine for this. You might make, but you can take an example where all the car is using that same type of engine, right? Next, I hope this is clear. In your syllabus point of view, this much detail is not required, but if in an exam it is being asked what is inheritance, try to at least write the different types of inheritance with an definitions and the different types of inheritance at least, right? That will give a better impressions, right? That you know extra stuff apart from what is given in your book, right? Next, polymorphism. Here, if you take this diagram or a picture as an example, you see this person is writing something, along with that doing a phone call, along with that drinking something, along with that preparing some charts, and so on. That means a single person is capable of doing n number of tasks, right? Similarly, here if you take an example of chameleon, what it does is it changes the color. It changes the color based on the surroundings. So what happens if the surrounding is brown, right? It will change the color itself to match to that environment so that nobody harms it, right? So that is what polymorphism is. Based on what is your role. Suppose if you are a mother or if you are a child, you play a different role. In your home, you might take care of your children. You in your office, you might take care of the project that you are working and so on. So a single person act in a different roles, right? Similarly, in the programming terms also, if you talk about, take an example of this. This is a very good example how you can remember what polymorphism means in programming language. You know, if I do an integer division, additions, 5 plus 3, here it will become 7, right? So if you add two number, so it will become, uh, sorry, 8, right? So if you add two numbers, it is giving you an addition, right? But similarly, if you add two string, it will give you concatenations. That means what? This single operator, that is a plus operator, is behaving in a two different way, right? Here it is doing an addition, whereas here it is doing a concatenation, right? So you can take this as an example for polymorphism. Next, modularity. So it is also very important. Suppose you are given a program to write, to develop something like Flipkart, Amazon, or huge applications. So the number of lines of code will be huge, maybe lakh, 10 lakh, 15 lakh, more than that, right? If you write in a single file, it will be very difficult to debug it, right? So suppose what happens, if your phone is damaged, you go to the repairing shop and say, like, my camera is not working. So he will just open the camera module and replace and fix it. He's not going to open entire module, right? He's not going to open everything. That is the beauty of modularity. That means you are breaking the bigger program into smaller part, right? Like you are writing the code for camera, you are writing the code for caller dialer, you are writing the code for n number of different features, right? And if one thing is not working, you are only going to check that particular part, right? So if you take an example, this is your very large application, right? Where you have sign in, where you do your login, sign up, right? Email, password, and your button to do the login, right? Similarly, you have the home page where all the products are displayed. You see, you open Amazon, Flipkart, right? You see the different products that are displayed, right? So for this, you can make one module that says the login module, right? Similarly, you can make this one as one module that says the home module, right? And similarly, you can break the code into different modules. And tomorrow, if something breaks, if somebody comes and tell you, hey, this login is not working, so you are not going to look into 10,000, 1 lakhs of code, but you are going to come into this module, only 100 lines of code, and you are going to see what is the issue, right? So it becomes very important to break your program into smaller modules so that in future, it becomes very easy to maintain that, right? Next. So modularity is very important. Act of partitioning a program into an individual component. That is what I was saying. Bigger program, you break down into individual components. Next. Very important point. This one is a very important point. Why Java is platform independent? In your board exam also, it can come of 5 marks, right? If you're in class 9, it is very important. Definitely it is going to come in your semester exam, right? To understand this point, why Java is a platform independent, let's first understand this thing, an ordinary compilation process. So what is an ordinary compilation process? Suppose in initial days, you want to develop something for a MacBook. You want to develop some software for a MacBook. You want to develop some software for a Windows. You want to develop something for a Unix. You want to develop something for your mobile phone that runs on Android, or maybe for iPhone that runs on iOS, right? So for all the different platforms, you have to write different lines of code. Suppose if you are designing some applications, you might be using some applications, right? Like a BlueJ, you have a BlueJ application where you write the code, right? Similarly, take an example. If you want to design a BlueJ for Mac that will run on Mac, then what you have to do? You have to write at least 10K or 20K or 50K of lines that will be in this particular language. Which language? Mac understand, right? Take an example. If you are in India, if you are trying to talk to someone, you will talk generally in Hindi. If you are talking to someone in US, you will talk in English. Similarly, in different countries, you will talk in different languages. Similarly, here to talk to different operating systems, you have to talk the language that they understand, right? So if you are developing something for this, you have to write in this language. If you are developing for this, you have to again write a new 10,000 of lines of code, right? And for this, again, you have to write 10,000 lines of code. So this was the ordinary compilation process where for each platform, you have to write a separate lines of code, 10,000 line for this, 10,000 line for this, 10,000 line for this, right? But in Java, this is not the case. In Java, there is a concept called ORA, write once and use anywhere, right? Write once and use anywhere. You'll write the code once. That is, you will only write 10K lines of code and you can use directly in your Mac, directly in Windows and any other platform, programming platform, right? So that is the benefit and that is the beauty of Java. Okay. Now, let's see the next slide. Then you will be able to answer the first question that we saw, why Java is platform independence. Take this example. Whenever you write any programs, right, you do a compile. What you do after writing the code, n number of lines of code, you click on the compile button, right? Everybody has written in BlueJ or maybe any online compiler, right? If you haven't seen, just a quick example, if I can show you, uh, let me see. Okay, let me try to open. Okay, let's see here. I'm opening any online editor, right? So you can also write the program in your offline editor, that is your BlueJ, any online editors, like I'm using some ID, online ID, right? Here you can see this is written in C, but our scope is C++. Let's try to change this to Java, sorry. And let me increase the font, right? So if you see this, whenever you write your program, basic program, class hello, this all syntax you know. If you don't know, just keep this basic point. Here you can see one button is there, run. If I click on run, that means first it will compile. Computer is not understanding what you have written. This is a high level language and computer understands the low level language, right? So whenever you click on run, it doesn't know where you are running, whether in Mac, Windows, doesn't matter, right? Just once you click on run, you are going to see, just let me run this. Okay, so if I click on run, I'm going to see the output. Maybe I have to lower down. Okay, we can see the output hello world, right? That means what is happening? Whenever you are compiling, it is getting converted. The source code, this is a source code, is getting converted into a machine code. What it is getting converted into? Machine code, which your system can understand, right? And who is doing this? This one is done by the compiler, right? So come back here. Let's see the diagram again. Now understand what is happening. You write any program and that program is saved with the extension .java. Okay. So you have written this program that I showed you, that 5 lines of code that was written. And if you save it, you can save it using .java. But when you compile this, when you click on compile, that file is getting converted into .class. What it is getting converted into? Initially you had a .java, now it will become .class. Got it? So initially we had one file named as code2serve.java, when you clicked on compile button, that is a run button, it got converted into dot class. And this dot class is basically your byte code. This class is your byte code, right? So what is happening in the initial days when you are trying to write any programming program, you have to write for this, you have to write for this, you have to write for this. But with Java, what happens? You are writing once in a high level language, that is in Java, and when you do a compile, it gets converted into an intermediate code. Directly it is not getting converted into a machine code. Rather, there is one intermediate guy, right? This intermediate guy is called bytecode. So if in your exam comes what is in bytecode, so you are going to say bytecode is an intermediate code between the source code and the machine code. It is an intermediate code, right? And what is the beauty of this? So you have written in one programming language once. Now this JVM, this is the architecture of JVM. JVM. JVM and this the full form is Java Virtual Machine. And what JVM does is, it is a responsibility of the JVM. It is the responsibility of the JVM. That means it is going to convert this bytecode and to a dependent machine code. What I mean by this? So you have written in one programming language, you clicked on compile, it converted into dot class, and now this dot class I told you is a bytecode. Now JVM is going to convert this bytecode into a machine code. So you don't have to take care. You write once, and now the work of JVM start. JVM will know I am running in Windows, I am running in Mac, or I am running in Android, right? That is the responsibility of JVM. Now JVM will convert into a dependent system. JVM knows I am running in Mac, so it will convert this bytecode into something what Mac will understand, right? Now, similarly, if I'm running that in Windows, JVM will convert this bytecode into what Windows understand, right? So that is the duty of JVM. So with JVM, what happens? It verifies the bytecode. First, this bytecode, whatever got converted, it first verifies, and that it interprets or compiles using the JIT compiler. The name of the compiler you have to again keep in mind. What is JIT compiler? The full form is just in time compiler. What is the name? Just in time compiler. And this compiler is present inside this JVM. You don't have to understand what JVM is, but just keep in mind inside JVM, there is different things. One is your bytecode, that bytecode verifiers, that verifies the bytecode and then convert into a dependent machine code. That's it. That is your work to just remember that there is something called JVM, and JVM is developed by whom? Java. Java gives you JVM, and with this JVM, his responsibility is to convert into a dependent machine code. Take an example of this translator. You know only Hindi. Now you have to talk in Japanese, you have to talk in English, you have to talk in Arabic, any other language. How you can talk? What you can do, you can keep one intermediator. You talk in one language, and that intermediator is going to translate into Japanese, English, and n number of things. So you only know Hindi, but you are able to talk to all other persons, right? So that is what JVM is acting as. JVM is acting as an intermediator. He is acting as an intermediator here. He is telling that, man, you give me in one language. My responsibility is to convert into a different machine language. So you don't have to write 10,000 lines of code here, 10,000 line of code here, 10,000 line of code here, right? So that is why Java is a platform independent. Now you got the point why Java is a platform independent. So what you have to write? Java is a platform independent because of this bytecode. First, what happens? You have to write all the theory, whatever I have told. So the first point, in Java, whenever we compile, the source code is getting converted into dot class, right? This dot class, the second point will be, this dot class is known as the bytecode, right? Then you have to explain what is bytecode. Bytecode is an intermediate code between the source code and the machine code. Point number 3 is done. Then you are going to say, inside JVM, there is a bytecode verifier. What is there? bytecode verifiers that verifies the bytecode and converts that bytecode into a dependent machine code. That's it, right? This is why this is platform independent. And you can also mention this term GIT compiler. Using the GIT compiler, it is converting the bytecode into a dependent machine code. That's it. I hope it is clear. If you keep this diagram into your mind, you can always answer the question why Java is a platform independent. Right. Let's move to the next topic, Java programs. Okay. So in the very initial, in the class 9, when you had started the programmings, right, you might have been told just to learn this or mug this up, right? What this is. So in class 10, we are going to remember or learn what this each word says, right? Or what this each word means. So let's come here. First point. This is a snippet of any basic Java program. So here you can see whatever is written in blue color, all those are keywords. What are they? All those are keywords. We are going to learn about keywords, but just keep in mind these are keywords. That means a predefined word that is developed by or name given by Java developers, right? We haven't given. It was given by the Java developers who has developed this Java programming language. So in here you can see there is different things that we can write. Like first one is your comment. You can see, suppose you are writing 10,000 line of code. Today you are writing that program. Some new developer will come tomorrow and something is not working. They are going to fix that. So how they will understand what you have written, right? So if you want to give them some message to any third party developer or any external developer, you can write what? You can write comments. Comments are not executed by the compiler. So whenever you click on compile, first line will get compiled, second line will get compiled, third line, and so on. It gets compiled. But whenever it sees a comment, it will ignore, and compilation will start from here. Got the point? So comments are not compiled by any programming language. It is just for a reference to an external developer or third any like a documentation, right? So whenever you write some notes, right, you write some extra stuff like why I'm writing this, what is this used for, right, what is the formula. Similarly here we write to just give a brief description for this what code is there, right? So here to write a single line of a comment, we use double forward slash. That means you can write only one line of code. If you want to write multiple line of code, you have to give forward slash, then you have to give asterisk, then again you have to close with asterisk, and then again you have to give forward slash, right? And whatever you write in between these are called comment, and these will be ignored by the compiler, right? And execution will start from here. This was the basic what you should know in class 9, right? Next. So here, anatomy of Java programs. What are the different parts of the Java programs? First, you came to know what a comment is. Comment will not be executed. Second is the main method. Third is a classes. And fourth is a code statement. So here, if you can see, first we talked about the comments. Second is your class. So here you can see the class. Starting point is class. And here we can see the main method. So all the executions start from main method. So suppose here you have 4 different functions, but your execution will always start from main method. Just keep in mind, like all the execution of any program will always start from main. Suppose you have class hello, and inside this you have suppose void show, you have void print, and you have public static void suppose main. I'm not writing the full things, right? So your execution, when compiler executes converts it into that machine code, but your always execution will start from here. It will ignore this. It will ignore this, and directly it will come to the main method. And if the main method is calling this, then this will get executed. If the main method is calling this, then this will get executed, right? That means always execution starts from where? Main method. If in a class, if there is a no main method, then that it cannot be executed, right? Next, code statement. So inside the main method, we can write the codes. So after this curly braces, we can write n number of lines of code. Next, let's move to the next topic, Java fundamentals. So to understand Java fundamentals, we have to understand the character sets. Okay. So what is character sets? This is very important. Character set is some kind of a symbols or words any programming language can understand. Like you understand English alphabet, A to Z, 1 to 10, these numeric things, right? You don't know what is written in Chinese or Japanese, suppose, right? You don't know. That is not in your scope because you don't know that language, right? Similarly, Java also understand up certain points of or certain sets of characters, right? So that character, we call it as a character set. And Java uses Unicode character set. Unicode character set. You will say, what is Unicode? So if you know ASCII, what is ASCII? It stands for American Standard Code for Information Interchange, right? This means there has been some standards that was defined, like each character will represent a number. So take an example. If you write capital A, that means it corresponds to 65. If you write capital Z, that corresponds to 90, right? If you write small a, this corresponds to 97. If you write small z, this corresponds to 122, right? So this is what a ASCII coding is. So here in ASCII, ASCII is of 1 byte. ASCII is of 1 byte. So I'll talk about how much character it can enclose, how much character it can keep, right? Now, this Java that uses is of Unicode, that is of 2 byte. It is of 2 byte. Got it? ASCII is of 1 byte and Unicode is of 2 byte. That means here we have 128 characters, but here we have more characters, right? We'll come to know how much characters can be accommodated into this 2 byte, right? Okay, just you got the idea what is Unicode, and the starting of the Unicode is from like this way, like you give backward slash, then you give U, then you give 0000. You have learned about the hexadecimal number. Hexadecimal starts from 0000 and it goes till FFFF. I'm talking about like you are having here this type of pattern, and U, F, 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 and in between there are so many permutation and combinations, right? And those all corresponds to a different types of characters. Like if you go to 65, it will correspond to this. 66, it will correspond to B. If you go beyond 128, it will correspond to some different languages characters, right? So this was what Unicode is. So whenever in your program or in your exam it asks what Java uses, Java uses Unicode character set that is of 2 bytes, right? This much only you have to understand. Next is your tokens, right? So what is tokens? Token basically is your building blocks, like how you construct your home. So if you construct your home, you will use the bricks, you will use the cements, and you will use different types of material, right? Similarly, in programs, if you want to construct a code, you will use different types of things in your program, and that smallest unit is called as a token. That smallest unit is called as a tokens, and you can remember the token with this KILOS. If you remember this KILOS, you can remember all the tokens what it corresponds. K stands for keywords, I stands for identifiers, L stands for literals, O stands for operators, and S stands for separators or punctuators, right? This is very easy. Now come to this point next. First is your keyword. You know, I already told you the place where I showed you in the blue colors, those all were keywords like public, all in a small caps, right? Right? Static, void, right? Class, and so on. List is so long, right? So keyword means what? Predefined word, right? Keyword are predefined word that has a specific meaning, right? So that is called keyword. Examples are this. Next is keywords. If you see an example here, if, else, while, do while, for an object-oriented programming, like we use class, objects, private, protected, and all. Data types, different types of container, we are going to just cover next after this. Int, double, float, long, short, and byte, and other type of keyword, void, return. We'll understand one by one when we go into the further lectures what this void means, what this return means, and so on. Next, literals. Literals are the fixed values of the data, like the numbers, like strings, characters, and etc. Like here, if you see 10, 3.14, hello, right? So here we have a fixed data, like it can be a number, it can be a string, it can be a character, that we call this as the literal. Literal can be of a different types. First, integer literals, Boolean literals, string literals, floating point literals, character literals, and null literals. So in integer literals, you can only store those which doesn't have any decimal point. Similarly, Boolean, you can only store true and false. So pay attention here, like if you write true and false, right? In Java, we write like this way, true or false. When you learn Python, in class 11 or 12, if you opt for programming language, right? Here we write F in a starting F as a capital and true as T as a capital. But in Java, we use all small cap. These are the point that you can keep in mind, right? Similarly, string is like combination of characters, like 2, 3, 4 character, n number of characters if you combine. Floating point is like for a decimal, I'm storing any decimal point. Similarly, character, this is very important. If you are learning Java, in Java, character is represented using a single quote and string is represented by double quote. But in any other programming language, if you learn JavaScript, even if you write single quote, even if you write double quote, still it is the same. Everything is considered as string, right? But here, if you want to write A, B, C, and if you put single quote, it will throw error, because single quote can be only used for a single character, not multiple of characters. For this, you have to replace with this, then this will work, right? Next, you have a null literals. That means you don't want to point to anything, then we can specify null. We will that is not in your scope, but just remember null literal is also there. Next, identifiers. What is identifiers? Identifiers are the name given to any blocks. Like, take an example, like in a program, we gave the name as a class. Here, the name was class hello. And inside this, we have void show, right? This is also a name. This is also a name. This is also a name, right? So these all are called identifiers using which we can identify. Even this is a name, int a is equals to 5, right? A is what? A name that we have given to integer variable. So there are some rules to name any variables or a class or anything. So what are the rules? You can start only with any characters. Any characters if you put, right? First point is any character. Any character. Second, I mean any character here means any alphabetical characters. right? Next, you can start with underscore, and the third is you can start with dollar. These three things only you can start with. You cannot start with number. If you name any variable like int a is equals to 5 we are doing, that is fine. But if you do int 1a is equals to 5, this is absolutely wrong. You can even do a1, that is still fine. The first character that you are giving should not be a number, right? This is what you have to keep in mind. And the remaining characters can be a number, can be anything. You can start with underscore. You can say int underscore a is equals to 5. This is also valid. So here I have written what are valids. So underscore is valid, dollar is valid, underscore is valid. Here you don't see any numbers, right? So these are valid identifiers. Constant means what? You can just declare one constant, that is its value is not going to change, then we call it as a constant. And in Java we define the constant using the keyword final. We will wrap up, two more slides we'll cover, right? Here is a final keyword, and using the final keyword we can define it as a constant. That means its value we cannot change it. Now here, as we have written final, now next time if we do tax rate is equals to 10, this will throw an error because this has been declared as final, and the final act as a constant, and this constant value cannot be changed anywhere in that program, and if you try to change it, it will give an error, right? Next, variables, that means whose value can be changed. Like if you write int a is equals to 5, now you can do a is equals to 6. This is valid, right? As soon as you write here final, that becomes constant. That means you cannot do this if you write final just before this. So that becomes constant. If you don't use final, that becomes variable, and you can change the value n number of times. You can again write 10, right, in the same program. This is the last topic that we are going to cover, that is a data type. This is very important. Okay. So what is data type? Data type is a container. Data types are a container, different types of container to store different types of values. So if you see the data types here, we have two types of data type. One is primitive. We can also call it as a intrinsic or non-primitive. That is a second type of data type. So primitive or intrinsic means what? What is predefined, what already exists in Java, that is called the primitive data type, right? And the non-primitive is what we design. We design using the combination of these primitive into a different type of data type that we call as a non-primitive. Primitive is not included by the program, I mean by the language, but we write it on our own based on the need, right? Like an example, class, arrays, and interfaces. So these two are in the scope for class 10. Interface is not in the scope for this class, right? Next, come here. There is a two category. One is a numeric, one is a non-numeric. So inside primitive, we see two types, numeric and non-numeric. Inside the numeric, we have integers and the floating point, like we discussed, integers, literals, and the floating point literals. So inside integers, we have how many types of containers? We have byte, short, int, long. We have float and double for the floating point. We have characters for char, and for the non-numeric, we have Boolean. The next important thing that you have to remember is about the size. Byte is of 1 byte. Short is of 2 byte. Int is of 4 byte. Long is of 8 byte. Similarly, float is of 4 byte and double is of 8 byte. And character is of 2 byte. Character is of 2 byte and Boolean is of 1 byte. You will tell why we are learning this, why we are learning the size. This is very important. If you are asked, what is the range? How many characters can be kept inside that type of data? So there is a formula to find it out. There is a formula. That formula is minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1, right? What I am writing here, this is very important. If you use this formula, you can find the range of any type of data, right? Here, here n is bit. Here n is bit, not byte. Here we saw like this is 1 byte. This is byte. All what I have written is in byte. All are bytes, right? 2 byte, 4 byte, 8 byte, all are byte. But here I'm telling, if you use this formula, you have to convert it into a bit. And then if you use this, you will get the range of any type of data. One example I'll give you. First, see this. If you talk about the smallest memory unit, that is called bit. And if you combine 4 bit, that becomes 1 nibble. The second memory unit is, first is bit, second memory unit is nibble, and the third memory unit is so if you combine total 8 bits, 8 bit, 1 bit, 1 container. Similarly, if you combine 4, that becomes 1 nibble. If you combine 8, this becomes 1 byte. So if you combine 8 bit, that will become 1 byte. Now, I'll give you just one example, and it will be your homework to find the different range of the different type of data type, right? So here, if I want to find the range of this byte, how many character it can store, right? Take an example. So here, if you see 1 byte is equals to 8 bit. So if we put the formula here 8, so what we'll get, minus 2 to the power 8 minus 1, that is equals to 7, to 2 to the power 7 minus 1. So 2 to the power 7 is what? 120, 128, right? From minus 128 to 128, this is 128, and minus 1, that is 127. That means this is the range of byte. This is the range of byte. So when I told you like ASCII is of 1 byte, 1 byte, then internally you have to think like the range is from minus 127 to 128. That means if you ignore the negative part, that means, sorry, 120 minus 128 to positive 127, minus 128 to 127. So if you ignore the negative part, what you will get the range? 0 to 127. That is total count. If you include 0 plus 127, that is equals to 128 characters. That means ASCII can hold only 128 characters. And in the world, 128 character is not enough. You have different characters. So that is why ASCII cannot hold all the character. That is why we have Unicode, that is of 2 byte. Unicode is of 2 byte. And now if you convert this 2 byte, that is equals to 16 bit. Now if you use the formula 2 to the power minus 15 to 2 to the power minus 15 minus 1, it will correspond to almost 65, 6,500 approx, if you try to find the exact number. That means that many numbers can be kept in the Unicode characters. Okay, you can pause the video and you can note down this formula, and you can take the snap of this, and you have to remember the sizes, and this size will help you to identify which type of container I have to check. Take an example. Suppose in your exam comes like you have to store your phone number. You cannot use byte. If you use byte, only 3 characters you can keep it, but phone number is of 10 long, right? So you cannot even use sort. That also corresponds to 6,500. So you have to take the higher container so that the range is larger and you can store a bigger number, right? So that is why you have to remember this. Okay, So if you have any doubt, post it in the comment. I'll try to answer all your doubts, right? For today, it's a wrap. We are going to cover the remaining topic in the next lectures.